Hello and welcome everyone. We will go ahead and get started. Thank you for joining today's webinar, Matter Security and Privacy, a deep dive with experts. A few logistics before we dive in. This webinar will be recorded and will be made available on the Connectivity Standards Alliance website. If you have questions throughout the presentation, please submit them to the Q&A box. At the end of the presentation, we will open it up for Q&A. If you have questions after the webinar concludes, please reach out to us at help@csa-iot.org, and we will get those questions answered for you. At this point, I would like to introduce today's speakers. With us today, we have Naama Bak, IoT Security Senior Business Development Manager at NXP Semiconductors, Steve Hanna, Distinguished Engineer at Infineon Technologies, Chris LaPre, Head of Technology at the Connectivity Standards Alliance, and Darren Learmonth, Distinguished Engineer at Silicon Labs. Before I hand off to our speakers, this is a quick view of our agenda for this session. Today, our speakers will cover an introduction to Matter security, privacy, and principles, threat models, including attack types and threat analysis, an overview of security and privacy architecture, and time permitting Q&A. With that, I will turn it over to Chris LaPre to briefly introduce Matter.
Thanks. Hello, my name is Chris LaPre, and I'm the Director of Technology here at the Connectivity Standards Alliance. And I'm here to provide an introduction to the Matter protocol to make sure you have a little background for the security information you're about to hear. So let's start with Matter. What is it and why do we do it? With Matter, members of the CSA set out to address two of the biggest issues facing the IoT industry and hindering adoption: consumer confusion and developer complexity. By using IP, the transport of the internet, along with a common language of the IoT based on contributions from members in the Alliance itself, we've built Matter, a common protocol which is poised to be the foundation for the Internet of Things. Matter is designed to knock down the walls of the walled gardens of the IoT, making it easier for consumers to choose the devices they want for their homes, as well as for developers and manufacturers to more easily and cost-effectively create interoperable products that they can sell for the connected home. Next slide, please. Matter is simple, interoperable, reliable, and as you'll learn a lot more later, secure. As a single mark, Matter is simple and easy to purchase for consumers. Device manufacturers can build their products with confidence and focus on innovation. Together, this means consumers will no longer need to wonder if a device they want will work with their ecosystem of choice. This is because Matter isn't just a standard in a specification. It's a full set of interoperable capabilities defined by our members. This includes a publicly available Apache 2 licensed, open source software reference implementation, complete with test specifications, test tools, and scripts. As always, with all CSA programs and logos, there's a complete certification program available for members. Matter was built using proven technologies tested at scale, which provide consistent, responsive, and reliable local connectivity that still works if the internet is down. Now, people can look for the Matter symbol and trust that devices and ecosystems will work together. Next slide. Matter development started at the end of 2019. Since then, we have seen tremendous progress. After over a year of development, in the spring of 2021, the Matter working group members approved the initial technical specification, and by the end of 2021, had completed 7 test events and pivoted engineering efforts from the specification over to the reference implementation. Now, in 2022, we have a number of milestones ahead to reach launch, which is planned for the fall of this year. In the first half, we'll complete the reference implementation and our test tools, and all of our members will have access to the 0.9 version of the specification. This summer, we'll hold our specification validation event, the final event that tests not only the full specification and member implementations end to end, but also ensures our test tools are ready too. Then, in the fall, we'll see the release of Matter 1.0. At that time, we'll expect to see the first certified devices, both new and upgradable, likely from one of the over 50 member companies who have been involved in our test events with over 130 different products in total. As part of this, we'll expect to see devices like what you see to the right: light bulbs, in-wall switches and dimmers and smart plugs, blinds and shades, thermostats and other in-wall HVAC devices, televisions and content, door locks and garage door openers, do-it-yourself security devices such as motion, contact sensors, keypads, etc. Matter will also support access points and bridges, as well as the multitude of devices that can be enabled as a control interface. And these products, compliant with our specification, will be built with strong security foundations. To hear more about that, I'll hand things over to Naama.
Thanks, Chris. Hey, hello, everybody from Europe. My name is Naama Bak. I'm with the NXP Semiconductor. So I'm going to give you an overview on Matter, security, privacy, and principle. Next slide, please. So Matter security, it's really about 5 things. Number one, Matter security is typically comprehensive end-to-end. First of all, is built on top of the transport layer, so Wi-Fi, Thread, and Ethernet, and dependent from that transport layer. So it's really new type of security, new security mechanism, including encryption, identity, and so on and so forth. And within the comprehensive, so Matter really covers it end-to-end from the first, from the manufacturing, including identity, strong identity injection, provisioning at the manufacturing, inside accessory. And that identity typically, it's going to be used by commissioner to prove, by commissioner, to make sure that the device is genuine, has not been counterfeited, and is not a clone. Secure communication as well, there is passcode based authentication, which allow the accessory to be authenticated and onboarded within a commissioner. And as well, certificate-based authentication for really node-to-node communication, but node-to-cloud as well communication. Matter as well recommend and cover things like secure operation. So there is secure boot, which is recommended to make sure that the firmware running within the device, its integrity is still preserved. And then Matter as well cover over-the-air updates, like mechanism, well described inside the specification, which allow typically developers to implement that inside their device. So this is about comprehensive. Number two, strong. Matter is built on a well-tested, well-known standardized crypto suite, including like public key cryptography. So we are using elliptic curve P256-bit nest curve, which is well-known for digital signature, and for key agreements. We are using AES 128-bit, typically for encryption. Again, well-known and scalable across multiple hardware platforms. And we are using SHA-2 for integrity, so for hashing. And we are using, like as I said at the beginning, passcode-based authentication and certificate-based authentication for secure communication. Number three, it's easy to use for developer, but as well for user. All the mechanism I was describing, typically they're going to be available like as a part of our open source, GitHub, including implementation of every protocol and crypto, but as well integration within multiple hardware platforms from multiple vendors, including secure elements, trust zone, trusted execution environment, but as well just any type of MCU and NPU. All of that really available within our GitHub. Resiliency is number four. Matter by design is resilient. And typically there are multiple aspects of resiliency there. First of all, protection against attack, like replay attack or DDoS attack, denial of service attack. And typically one of the examples, just to give you an idea, every message that is exchanged between nodes, it typically has a counter. And that counter typically it's something that can be used to do like anti-reply attack and DDoS attack. Other thing about resiliency, Matter rely on what we call DCL, distributed compliance ledger, which allow every vendor typically to put his ID, product ID, public key, and really many information about its product itself. And that ledger typically is distributed, so there is no central server. And that allow typically commissioner to check all the time live if a device is genuine, if the firmware running within that device, it's the latest version, and if it needs to be upgradable typically. So that's one of the type of thing we do in terms of resiliency. Matter is as well agile, and we are thinking, as we all know, there is no security without updates, okay, without maintenance. All of that crypto suite we are defining today, it needs to be upgradable, updated in the future, because key length, we know the threat model, it's evolving, and the key length that is valid today may not be maybe valid in 10 years from now. And so from agility perspective, the spec abstract the crypto layer. And if we move to a new crypto, typically like key length and so on and so forth, the spec does not need to change 100%. And so there will be a kind of discovery or negotiation mechanism between node where they can agree typically on a specific version of the spec to use, and then in this case, a specific type of crypto suite. So really bottom line about those 5 things, Matter is end-to-end secure, functional security built on top of that transport layer. It provides strong, well-tested, well-known crypto suite. It is easy for developer, but easy as well for user. They just need to read out a QR code to get the device onboarded, and then they don't need to configure anything. Resiliency to protect against attack, and then agility to think about the future. But there is as well the aspect of privacy. So Matter by design implement mechanism that allow to provide privacy for users. And as we discussed, every data exchange between the node, it's encrypted. So we protect typically the confidentiality of the user data. The messages between the node, they can be encrypted, including the header, which include typically a unique random identifier. So there is no tracking typically of node, and it's super difficult to make it. And since that unique identifier, it's a random, so we see it changing at every session. So a lot of mechanism within privacy, but we are really rising the bar there. And one of the things to add there as well, since there is a strong identity for every unique node, then if there is a third party that try to join like a fabric or an ecosystem, it's going to be hard because it does not have an identity which is valid. So that's from a privacy perspective. I'm going to move to Darren, who can explain the threat model.
Hi, I'm Darren Learmonth with Silicon Labs. As the Internet of Things connects more and more devices and systems, the risks of cyber attacks and compromises increases too. To address this threat, as we've seen, security and privacy are key design tenets of Matter. Using these design tenets, we analyze the threats we may face and the countermeasures we could specify to address these attack surfaces. In effect, the team have taken a threat assessment and remediation analysis, or TARA approach, to teasing out the actors, the attack surfaces, and the countermeasures that we could deploy. Here we look at the landscape of attackers, and we thought long and hard about the reasons or the motivations for an attack. Was it personal, for example, a disgruntled ex-partner? Was it financial, an attacker trying to get access to data that could be monetized? Or worse, provide access to your bank accounts. Further, we categorized each attacker with capabilities. What resources do they have at their disposal? And they certainly are not limited to time, money, and tools. What expertise might an attacker have? For example, they may have a unique skill set, or they may have insider knowledge as to how a product or a network was built that they were trying to attack. And what kind of access would the attacker need to perform their attack? Is it physical access to the product? Or are they networked in from the bedroom on the other side of the world? Or are they sitting in a car on the other side of the road to your home? What role does the attacker take? For example, you invite a guest into your home and they have physical access to your camera. Could they somehow change the configuration and watch you in your home after they have departed? And finally, we look at the attack surface during the life cycle of a product. Is there an attack surface when it's first unboxed by a new owner? Or when it's purchased secondhand or refurbished by a new owner or trash picked? Next slide, please. We also considered a breakdown of attacks from the perspectives of what are the targets of the attack and what are the methods of attack. The targets of the attack obviously contain Matter-enabled devices themselves. And these devices could be sensors or alarms or appliances or really anything enrolled into a Matter network. But we also considered exploitable design flaws or implementation issues in the algorithms. We considered the gateways, because we know there will be bridges and routers in many Matter networks, but also legacy devices And do these expose vulnerabilities in certain combinations? The methods of attack are equally important. For example, can you eavesdrop or jam the network itself? Has someone discovered an effective exploit in the protocols? Can a trusted person be tricked or influenced to attack a network or a device? Identifying the target and the method gives additional strength to our analysis. Next slide, please. Every single threat has been analyzed so we understand how serious that threat is. The severity of the threat allows us to decide on the importance of addressing the threat, either in the protocols, the operating modes, or an advice to or requirements on product builders. The severity of a threat is a combination of the likelihood and the impact, and both likelihood and impact are further broken down. The access vector should be simple for everyone to understand. Does the attack require physical access? Is the attack possible from a car parked across the street from your home? Or can this attack be done from a bedroom on the other side of the planet? We assess the difficulty of the threat based on how hard the threat is to create and use. As an example, we rate a threat as easy if once that attack has been developed, it's trivial to attack additional victims and does not require a compromised or malicious device. We define the impact as the effect of the successful attack. And just as we assess likelihood from two perspectives, impact is the same. The scope of the attack tells us how large the compromise can be. For example, if a developed attack on one device can be extended to all similar devices, then this complete fleet attack is pretty serious. The other impact of the attack is what does the attacker get access to? This measure ranges from really low sensitivity data to every piece of data in a device without the owner being aware. Next slide, please. So far, I've talked a lot about how we develop the threat model. For every threat that we identify, we attempt to mitigate that with a countermeasure, or more than one countermeasure. We have identified a great many countermeasures, and in our analysis, we link as many countermeasures as we can to each threat. This is mostly not a one-to-one mapping, and many countermeasures are reused to address many threats. Many of the countermeasures have been included in the matter specification, and you'll find them in many forms throughout, either formally included behind words as must, such as must or should, or mentioned in the text not as a requirement, but more as passing advice to product developers. But with all of my explanations, there's nothing to give more clarity than looking at an example of a threat and a countermeasure. So let's expose one of each. In the top of this slide, we see the threat. Every threat is attached to a tiger team. That's the column applicable TT. And in this particular instance, this is owned by the threat model tiger team. Other options for ownership are the other tiger teams and technical groups, such as the device attestation tiger team or the secure channel tiger team, for example. Every threat, for tracking purposes, has a unique identifier, and this is threat 59. To allow you to gauge the level of effort that many people have contributed to this, we currently have almost 200 threats in our database. This threat explains an exploit using a malicious message targeted at a device, allowing the attacker to compromise the device. The consequence of that compromise could be many, but we always choose the highest consequence. And that is that the trusted device could be hijacked and sensitive data extracted. Or the device could be hijacked to create other malicious messages. The severity, impact, and likelihood are computed from considerations on the breakdowns I shared earlier for impact and severity. In this particular case, for all the severity, impact, and likelihood, this threat has been rated as high. The countermeasure exposed here is countermeasure 58. And as it is currently written in the specification, nodes shall support over-the-air firmware updates, either using Matter-provided means or proprietary means. And then we tag that countermeasure with its linkage. So this is countermeasure 58, and it addresses threat 59. Again, we have nearly 200 countermeasures in our analysis, of which many are present in the Matter specification in one form or another. It is worth noting that each threat may have one or more countermeasures, or indeed just one. I hope that as Steve presents the next section, you'll keep the threats and countermeasures in mind as he explains more of the architecture that has been developed.
Thank you, Darren, for describing the process we've used to analyze and enumerate threats. So how do we defend against these threats? Matter includes many layers of protections. The first layer is identity. Every Matter device has a unique identity built into it so that the consumer can know with confidence exactly what they're bringing into their home. In this light bulb from the Bulby Corporation, we can see that it has a device attestation certificate with its unique identity listed there. That certificate is sort of like a passport, a signed statement regarding the identity of the device. And you can see the certificate includes a unique subject name and public key for the bulb. It also includes ID numbers identifying the vendor and the product, such as, in this case, model line 298. The device attestation certificate chains back to a root CA for device attestation, and of course, it's matched with a unique private key that you can see on the right there, stored on the device. And here, as Naama mentioned, we're using the same public key infrastructure, or PKI technology, that web browsers use to authenticate websites. But in this case, we're using it to authenticate an IoT device, not a website. So as noted earlier, we're using strong, well-tested, and well-established techniques to secure the smart home. What else is in this bulb? If you look in the lower right corner of the slide, you can see that the bulb also includes a certification declaration, or CD. That's a digitally signed statement issued by the CSA indicating that the vendor ID and product ID included in the device attestation certificate for the bulb have been tested and certified. That particular vendor, that particular product ID were certified under CSA's Matter certification program. And you'll also see down there a verifier, and in the upper right-hand corner of the slide, a QR code, which enable mutual authentication during the commissioning process. So what is this commissioning process? Well, that's the way that consumers use to securely add a device to their home, as you'll see on this slide. Here I'm going to show you the user's view of bringing a device into their home. So in the first step in the process, the device is manufactured. All those initial device credentials get installed, as you saw on the last slide, and it's shipped to the store. In the next step, the consumer goes out to the store and they fall in love with that device and they buy it and they bring it home. And now they're ready to install it in their home. So they introduce the device to the commissioner. In this example, it looks like it's a smartphone they're using as a commissioner, but it could be a tablet or a smart speaker. And let's say they scan the QR code there. Now this triggers a commissioning process during which the device is authenticated using that device attestation certificate, and also the verifier and QR code. And the commissioner verifies the device and makes sure that it is authorized to connect to the home, that it's been properly certified by CSA. And then the device is commissioned. This happens without much need for user involvement and allows the device to obtain the credentials that it needs in order to participate fully in the smart home, the user's smart home. As you can see, this process is really quite easy for the consumer. They didn't need to worry about passwords or PINs or IP addresses or anything like that. Just to recap, they scanned the QR code on the bulb, and with a few confirmation steps perhaps on their phone that they wanted to add this bulb, it is now added to their network. Now, if I were just talking to ordinary folks on the street, I might stop there. But since this is a security talk for security experts and by security experts, I'm going to give you a few more details about what's happening behind the scenes here. So in this next slide, we can see what the light bulb looks like after the commissioning process. Like a child that's adopted into a family, the bulb now has a new name that will be used within its new family. At the top of the screen, you can see that name. And the name in this case is composed of a fabric ID, which is shared by all the devices in this home, and a node ID, which is unique to the bulb within the home. That's, in this case, fabric ID Acme root.f1 and node N6. To prove its name, the bulb has obtained a new operational certificate, which is like a passport with the new name in it. That operational certificate will be used henceforth for all communications within the home, and it chains back to an operational root CA that is trusted by all the devices in the home. So you see we're using this same public key infrastructure or PKI technology that we used earlier for the commissioning process with the device attestation certificate. Speaking of the device attestation certificate, you can see that it's still there on the left side of the slide. It stays on the bulb for possible later use. For example, if that bulb is sold or given to somebody else and it needs to be commissioned into a new smart home. So what else was installed on the bulb as part of the commissioning process? Well, if you look in the lower right corner of that rounded rectangle, you can see, of course, the private key. That goes without saying. Any public key certificate that's going to be used for authentication needs to have a corresponding private key known only to the bulb. But also you'll see an access control list, or ACL as we call it. And this ACL, well, it's a technology which if you are a security professional, you'll certainly recognize. It's what controls which other devices are permitted to connect to the bulb and what they're permitted to do. So in that example we just saw, where the bulb was configured and then could be controlled by a light switch, well, probably the ACL would say that the light switch in question is permitted to turn the bulb on and off. But probably it would not permit the light switch to perform administrative tasks on that bulb. No, that would be reserved for, say, the smartphone that was being used in that example. So here we see different levels of access for different devices within the home, and all authenticated using these operational credentials with mutual authentication and, of course, secure communications, encrypted, authenticated, integrity protected, replay protected, and all the things that we expect from today's secure communications protocols. Before we leave this slide, I want to call your attention to the operational network, the last item there in the lower right of the bulb, that indicates and signifies the information that the bulb needs in order to connect to the operational network inside the home. So if you're using Wi-Fi, probably an SSID and a password. If you're using Thread, it would be a set of Thread network keys, whatever's needed there. All right. So on this next slide, I just want to point out that Matter substantially raises the bar for IoT security and privacy. In fact, I think it's fair to say that the introduction of Matter constitutes the largest improvement ever for IoT security and privacy. Admittedly, that is a bold claim, but I'm going to back it up with some evidence here. Let's run through some of the things that are included in Matter. The first one here, from a security perspective, is easy, secure, and flexible device commissioning, as was just described. You see how easy it is for the user, how well it's secured, and how flexible it is to support a variety of different communications techniques. Now, the next one is validation that each device is authentic and certified, and that is the device attestation certificate and the certification declaration that I mentioned earlier. To continue the description of what's included, we have the distributed compliance ledger. This is a blockchain-based system which provides for global distribution of up-to-date information about device compliance and certification. So for example, a check can be done to make sure that the device in question is actually certified and supported, what's the latest version of the firmware, and all of these sorts of things. So that's not required, but a very beneficial thing that's included in Matter to provide that timely information on a global basis. Strong identity for devices. Well, I showed you that. That's the operational certificate that's installed on the Matter device as part of the commissioning process. The big benefit here, in addition to secure communications among the devices, is to make sure that only your devices can join your smart home, because only they have the necessary operational certificate in order to do so. The next item is the secured unicast communications, leveraging those operational certificates to permit the bulb and the switch to communicate securely with each other with mutual authentication, encryption, integrity protection, all those things that I mentioned earlier. It's really a high level of expectation. Secured group communications is next. This is something that is unusual in IoT environments. The light switch will want to be able to perhaps turn on many bulbs simultaneously or turn them all off at once. If we had unicast communications only, that would be limiting in that you would have to send separate messages to all those bulbs, a waste of bandwidth, and something likely to result in latency, the popcorn effect where bulbs turn on at different times in sequence. Instead, with group communications, a single message can be sent securely to all the members of the group so that they can know that it's time to turn on or turn off, or whatever the command might be. Beyond group communications, we have multi-admin, as we like to call it, a really unique feature for IoT security, the ability for the user to choose multiple administrative devices and controllers from any manufacturer that supports Matter. So let's say there's a husband and wife and they have different types of smartphones that they prefer. That's okay. They can use both those phones together in the home compatibly. Smart speaker, whatever it might be that you want to use to manage your devices, you'll be able to use them and use them together in a compatible manner. Really extraordinary, and as far as I know, unprecedented for smart home. I mentioned already the access control list, and just to point out here that this level of fine granularity in access control is quite unusual in smart home, to be able to say on a vendor-independent basis that a particular device from one vendor can control certain aspects or read certain attributes of a device from another vendor, to have that operate securely across those different vendors is extraordinary and highly beneficial. We see this example in this animation where the bulb tried to send a command to the switch, and well, that's not the way it's supposed to work. So the access control list on the switch has rejected the command from the bulb because that's not something it's allowed to do. We include also a standard mechanism for performing secured software updates. As we mentioned earlier, we understand that it is essential, and I think you all do as well, to provide software updates for any IoT devices out there in the field. Things change constantly, and we need to be able to enable devices to get those updates so that they can stay secure, whether it be a new vulnerability that's been discovered or perhaps some improvement that's been made to the device. It's essential to maintaining a happy home that you'll be able to get those devices installed and to do so securely and simply. And finally, we have verification of software integrity. This is something which is quite unusual in smart home devices, the ability for an administrative device to verify that the software installed on the device has proper integrity, that it hasn't been tampered with, and that it's the latest version that's needed. So this capability is included in Matter as well. As I look down this list, I see many of these things, which are, if not unknown in the IoT community, certainly rare, and which provide real benefits in terms of user capabilities, such as multi-admin, such as secure group communication, and benefits from a security standpoint as well. So yes, Matter has raised the bar for security and privacy in the smart home and IoT, but we will continue to raise the bar in that manner. This is always a cat and mouse game, if you will, or spy versus spy, if you remember that cartoon. A constant contest between attackers and defenders, where defenders introduce a new high level of protection, and then attackers figure out some way to get around it, and then the defenders, and then the attackers. And we try to stay ahead of the attackers, yes, but we know that we will need to continue to raise the bar in order to do so. So how are we doing that? Well, CSA has a program of positive engagement with security researchers. We offer open source access to our SDK and open access to our specifications to encourage security researchers to analyze them, to look for ways that they could be improved, and to, if they discover vulnerabilities, report those vulnerabilities to us immediately so that we can get software updates out there through a responsible disclosure process. And beyond that, we have a plan for continuous enhancements to the Matter design and implementation to continue to improve and advance the state of the art in security and privacy within the smart home. If you would like to be involved in these discussions, I would encourage you to join CSA And as I've said here, you don't have to. You can report vulnerabilities to us, certainly through our process. But if you'd like to contribute to actively improving the security of the smart home, the best way to do so is to join CSA. You can learn more about that with the link there, buildwithmatter.com. And now I'd like to throw the floor open for some of your questions that you've been submitting during the webinar. You can continue to submit them in the Q&A section of the Zoom webinar.